Welcome everybody. Thank you for coming to Chapman Construction's 6th Continuing Education Seminar. I'm Guy Compagnoni. I'm the Director of Sustainable Practices here, and today we have a terrific presentation in store. As a reminder, for AIA members, please be sure to sign in and put your AIA member number so we can give you credit. And for those LEED APs that have enrolled in the GBCI CMP program, please also check your name over there and we can provide you credit for that as well. Today's topic is commissioning within the LEED rating system, and we are really fortunate to have Stephen Rizzo with us from Synergy Consultants. Steve is the president and founder of Synergy Consultants. He's a graduate of Northeastern University College of Engineering, a registered professional engineer, and an ASHRAE certified commissioning process management professional. In addition to an extensive bio and portfolio of projects, he was the commissioning provider for the Harvard Institute Medicine Project, the Shapiro Clinical Center at Beth Israel Hospital, the Ambulatory Care Center at the University of Illinois at Chicago, and the Biomedical Research Building at the University of Pennsylvania. So, welcome, Steve. Thanks for coming.
Hopefully I can put everybody to sleep quickly. We're here to, I'll just give you a little introduction to us. We've been in business since 2003, and we got into the business doing primarily medical work. We've sort of morphed into LEED as it has developed, and the services that we provide are commissioning for HVAC, plumbing, electrical. And you can read this as much as I can, but LEED is a piece of our business. It's probably about 50% of our business. The other 50% are private clients, healthcare institutions, and others. We have completed about 25 LEED projects to certification. Almost all of them are silver or better. Have not done any platinums though, mostly silver and gold. We currently have about 10 on our books right now that are in at some stage of completion. Some are further along than others. So let's talk about, what we're here to talk about is how the commissioning process works, how it fits in with LEED, and then a little further along I talk about how you select a commissioning agent, what their scope of work should be, might not be, and so on. So starting with commissioning itself, just as a way of defining what commissioning is a process. The whole intent of the process is to prove that the building is performing the way it was intended, which is why it's important for us to review the owner's project requirements. And we're now at a point, whether it's a LEED project or not, that we're advocating that owners develop their own project requirements, even if it's not a LEED project, because it gives us a basis of the goals that we want to set and the performance standard that we're trying to meet. When we develop our commissioning plan, that process that we're talking about is done under a formal commissioning plan. We write a commissioning plan for every project that we work on. I actually have put around 3-ring binders some examples of our work. The binders are actually finished product at the end, but the commissioning plan is in fact the beginnings of that. And as we go through developing a plan for a building, we look at all that stuff. But commissioning is a proactive process. And if I go into this, in the old days, as much as 5 years ago, this was pretty much a project team. Architect, engineers, owner, general contractor, everybody did everybody kind of knew what they needed to do. When I first started in the business, we used to pride ourselves on putting out documents with no addendums. How many jobs have anybody done in the last 10 years that have no addendums? One reason for that is because we were given time to do the designs, and you guys were given time to build it. And you don't have that time anymore. Time is money. Money is time. So since then, we've had two things happen. Not only have we lost time, but we've added complexity. Not only have we added complexity, but we've added integration of the complexity. where the HVAC system controls have to talk to the fire alarm system, which has to talk to the smoke control system, which has to talk to the fire protection system. You got pre-action systems, you got delayed action systems, and so on. So it all starts to come together. And what commissioning has pulled in for us, or what commissioning can pull in for you, is as this complexity has grown, commissioning has strived or tried to pull the gaps together. The example I like to give is when you're working in a chiller plant and you have the chillers, the pumps, the boilers, the air handling equipment, and all this stuff that goes together, but you also overlay on top of that the refrigerant detection system and the ventilation that goes with that, and then you have the fire alarm system that has to overlay on top of that. The electrician is responsible for one piece of it, the sprinkler fitter is responsible for a different piece of it. Each piece is tested within itself, but who tests the whole? Who makes sure that when you pull the plug on the central energy plant, does the generator start properly? Does it serve the building systems that it's supposed to serve? What we try to do with commissioning is to fill in those missing pieces in the integration and the coordination. So our intention is to try and pull all this complexity together into a commissioning plan where we test the lighting systems. We'll go so far as to test the daylight harvesting. Does it work? Doesn't it work? When the lights turn on, turn off. I can show you, I have a couple of examples later where we did some of that. High efficiency heating equipment, is it putting out? Can we document that? We do very little with building envelope personally, but we have worked with other envelope vendors as part of a whole commissioning to do the building envelope. We've also done gray water. We've done water treatment systems for pH neutralization. And it's what we try to do is we try to build our systems so that we're testing the devices first, because we need to know that the controls for each individual component are not lying to us. And then we try to build from those components to the individual systems. And my definition of a system is something or some assembly of things that produce one product. An air handling unit can have 30 points in it, or 30 DDC points in it, but it's got one product to do. It's going to move X amount of air at a given temperature at a given pressure. To me, an air handling unit is a system. We'll test all the individual components. In the commissioning reports that you have around the room, you'll see checklists. We do a lot of checklists. We do a lot of installation checklists. We do a lot of performance checklists. Our goal is to make sure that this system that's put into this complex structure that we've built performs to the owner's intent. We try to stay out of design discussions. Every engineer can design a good job. And I think everyone in the room would agree with me. You get good people, you get good designs. You get lousy people, you get lousy designs. But for the most part, we haven't found a design that couldn't be made to work one way or another. So we don't do an awful lot of, we don't spend a lot of time in the peer review phase talking about alternative systems unless there's something obvious that would save energy. And I think that's kind of where LEED goes. So as a commissioning agent, some of the things that we do an awful lot of measuring. We do an awful lot of trend logging. And this was a guy I was working with. We were doing an emergency power test in a building. It was a 300,000 square foot building in Boston. And we were pulling he was actually opening the 15 kV breakers. We had two lines that fed the building. We opened both breakers so that we could demonstrate that the building under a normal power failure or a simulated total power failure would work properly. And then what we did is we had him work and restore a portion of it. Say for example, we lost only one line. What happens? Did the generators start where they're supposed to start? This was an interesting job in that we had automated tie breakers. So the network gear was double-ended but had normally open tie. So if we lost a feeder, did the tie breaker close? If the tie breaker closed, did the generator still start? And we documented that whole sequence all the way through. We also do HVAC equipment. I've brought some of my equipment here. I didn't bring all of it. It's a little bit too cumbersome to bring, but we typically rely on a TSI VelociCalc for the most part. It's a NIST traceable temperature and humidity sensor. It allows us to record pressures. We do a lot of isolation rooms where we're testing to make sure that the isolation room pressure is proper. We do a lot of thermostat calibrations. There's some photographs in here of some of the work that we've done in the past. I talked about daylighting and so on. Benefits. Commissioning has an awful lot of different benefits. When I first started doing this, the biggest benefit seemed to be warranty callbacks. We like to say that if we've tested it in the field, there's no design errors because we've stressed the system to a point where we know that the systems work properly, and there's no installation errors because, again, we've stressed the system, we've checked the flows, we've checked and Rich Elliott will tell you that we do an awful lot of checking. They do. Our goal is to make sure the building works. That really is our goal. We want to make sure that the designer who spent an awful lot of time designing it did a good job. We want to make sure that the guys who installed it did a good job. And our job is to document that. As things have gone on with LEED and building optimization and performance, we're getting more and more into peer review. We're getting more and more into operation and maintenance review. Can a cooling coil be removed? Can a motor be removed? Can a shaft be removed? Can the bearings be greased properly? Is the system available to be maintained properly? We've gotten more and more into that. We've gotten more and more into providing documentation for automated PM systems. The Commonwealth of Massachusetts actually wants us to put all the O&M documentation on a CD, which we give to their Camas people, and they do the input, but we're doing the final documentation. We're reviewing as-builts. We're reviewing O&M. In a lot of the LEED projects that we're doing now is we're documenting the IAQ point for flush out. So if a building wants to be flushed out at 100% outside air, how many days does that take at the CFM that's available? Was it really done properly? Was it maintained at above 65 degrees below the required humidity? We'll document that kind of stuff with trend logs. So we're getting more and more involved in that. Some of the benefits that come out of it are they're really kind of hard to explain because if there's reduced warranty callbacks, they're saving money, saving you money, saving complaint time, and saving occupant time because they're not picking up the phone to say my temperature is off, something doesn't work. So there's indirect savings. There's also energy savings in that we know that the systems are working properly. Time clocks functions are working properly, reset schedules are working properly, and so on. So as a way of coming at what does commissioning save, the Lawrence Berkeley Laboratory, under a grant from DOE, worked with Texas A&M University, their energy center, and they studied 20,000 buildings built since 1975, I believe. And they just recently reissued the study that they put together. That study showed that the non-energy benefit, that lost time for calls and callbacks, came to around an average of about 17 cents a square foot per year in savings. The energy reduction was about 14 cents per square foot. Just from what they did is they looked at buildings that were not commissioned, they looked at buildings that were commissioned, they looked at all sizes, they looked at all types, they looked at schools, they looked at hospitals. The problem with the numbers is less complex, less savings. More complex, more savings. So you have to kind of be careful about how you quote that numbers, which those are the only numbers I will quote because they're documented. Now, another claim that they made, and I do somewhat agree with because I've seen it happen, a building that is not commissioned will typically run about 8 to 20% more in energy cost. Now you know why LEED is anxious about buildings, that buildings get commissioned. It's also why a lot of the state people are working towards getting commissioned. So what do we do? LEED has 2 points for commissioning. One is fundamental, and it's a prerequisite point. And this is basic commissioning. This is the building's already built or somewhat in construction. We come in and we test it. We document the tests, upload it to USGBC, and we walk away. Typically we do the energy saving systems, and we can do anywhere from 100% of everything that operates and uses energy, or we can do a sample. Their method, and the ASHRAE method, allows us to do a statistical sample. The problem with, there's issues with statistical samples, and I'm going to just kind of keep moving on it, because some people prefer to see 100% testing, some people want to see 50% testing, and we'll get into that a little bit when we talk about commissioning agents scope. In essence, we don't do peer review as part of this, although we will, because we want to know what we're commissioning. On enhanced commissioning, it changed. It changed to 5 points, right? Because they want people to do this. This gets a little more involved for us because it requires us to spend a lot more time with the OPR. And it requires us to spend a lot more time focusing on the design. And this is where they actually say we're supposed to do a peer review. And we do a much more formal peer review. We'll submit the comments that we make on design to USGBC with the engineers' responses. And we actually keep track of it. We do a DD review, we do a CD review, we do a post-CD review, and all that gets uploaded to USGBC. This next slide is a little hard to read, but this kind of gives you all of the, you can see what happens with our scope when we go from fundamental commissioning, which is your basic prerequisite, to enhanced commissioning. And you see designated the owner is supposed to designate as the commissioning agent before 50% CD. We review the OPR and the BOD. We get involved with the design review at 60%. We develop our commissioning plan. We review the submittals. The enhanced commissioning requires us to review the submittal simultaneously with the engineer. It doesn't say anything about how we're supposed to process our comments. It just says we're supposed to do it. Now, what we typically will do is we'll review them and then pass to the engineer, who's the approving authority, our comments. And we either agree or agree to disagree. We certify the installation, we do our functional performance testing, and then we create a manual. And this manual is supposed to allow the building operators, if anybody's doing operation maintenance, it's intended as a living document that allows people to maintain buildings and understand what they're maintaining. Good example is we did a low temperature chiller for Children's Hospital, which had 68-degree ORs that were doing hard work. And it was difficult for the guys who were maintaining that HVAC system to understand why this chiller ran when it ran, or why it didn't run under other conditions. Turns out, the way the controls, we ended up optimizing it so that under certain dew point conditions, the chiller didn't have to run, because you can drive the OR temperature down without having to do a lot of dehumidification. So in that scenario, you don't need really cold chill water. You can just drive the dry bulb temperature down. When the outdoor dry bulb is higher, or the outdoor wet bulb is higher, sorry, you need the colder chilled water. So this chiller would turn on at odd times, and the guys who ran the building didn't understand why. The systems manual is supposed to help overcome some of that. That's an unusual situation. But in almost every job we do now that's a VAV job, there's static pressure reset, there's temperature reset, and that's all to optimize either horsepower or electrical consumption for chilled water. And the systems manual helps to explain why those things happen. Because you'll look at a system one day and it'll be 5 inches of static set point. You look at a system the next day and it's 3.5 inches of static set point. Why? The manual is supposed to. We verify training. We don't do the training. LEED requires us under the enhanced credit point to verify that the training was done and it was done well. It also doesn't require us, it only requires us to document that the training occurred. It does not require us to submit attendance records, although we do that because it's the best way to show that the training occurred. So some of this stuff is a little fuzzy in terms of what USGBC is asking us to submit. We do a building operating review at 8 to 10 months. And we try to do that on every commissioning job that we do for 2 reasons. One, we can commission a building in the summer, and there's a whole bunch of the heating system we never see, humidification in particular. We also have found through that kind of review that there are latent warranty issues. And the question is, what do you do about those latent warranty issues? Doing a project right now where there's been repeated bearing failures on a pump. And whose warranty? The warranty's almost up. I mean, the standard 1-year manufacturer's warranty is up. The contractor's warranty is coming to an end. Whose warranty is that? It's a latent problem. So the warranty has no end until it's resolved, and then it's a 12-month warranty after that point. Are there things like that that have occurred over the first year of operation that need to be resolved, flagged, whatever? We had a project where back in the days when we used adjustable vanes on vane axial fans, they were diaphragm operated, and the diaphragms had a little rotary union which cost about $175. The rotary unions were failing every 3 months. It was 13 hours of work to replace one. First year labor warranty was fine. Cost of the rotary unions is nothing. Manufacturer was just kept shipping new rotary unions. But 13 hours of man time. They redesigned the rotary union, they fixed the problem, and now they last 5 or 6 years before they have to be replaced. Of course, with the advent of good VFDs, they've fixed the blades in place, they got rid of the pneumatic operators, and that really resolved the issue. So the building operation after 8 to 10 months, we're also looking for things like, did this work? You know, everybody makes assumptions in design. You have to. There's compromises in structure, the ductwork doesn't fit, the ceiling has to be lowered, the ceiling has to be raised. Every design has compromises. Did it work? Did it really work? If there were pieces of it that you would do over again, what would you do over again? So we try to bring those lessons across to newer projects. Not a LEED requirement, but something we like to try to do. Almost a lessons learned workshop. This slide is regarding the owner's project requirements. This is intended to set our goals. So as we're developing our commissioning plan, we try to review what's the owner trying to do. Are they trying to attain a platinum rating? Do they want to maintain 75 degrees plus or minus 1? Do they want to maintain 72 degrees plus or minus 1? I've got a client that wants to hit 70 plus or minus a half a degree. It's a specialty lab, but they do happen. And the project requirements allow us to weed out an awful lot of that stuff. And it allows us to build our commissioning plan to demonstrate that those things actually did what they were supposed to do. Now, I never expect an owner's project requirements to tell me how the building is supposed to perform in a power failure on at 3 a.m. on the 4th of July. The basis of design tells me that. The basis of design tells me what the systems are. It tells me what the criteria is for temperature, humidity, what the design assumptions are. When we do our peer reviews, we'll review these documents, and then we'll review the design and say, hey, wait a minute, in the design, in the OPR and the design requirements, you said this, but this design doesn't reflect that. That's peer review. In my mind, I'm looking at what the good engineers that people have hired and the good architects that people have hired have come up with for a design that meets their intent, and just making sure that it's executed properly. I'm not going to spend a lot of time arguing over, you should have used a 4-pipe fan coil system here instead of a VAV system. I'm not going to do that. It's a waste of everybody's time. It's a waste of a lot of money, too. Scope of work. Design phase, I talk about peer review. We do write a specification that has coordinating language in it that says, you shall cooperate with me when I need help. You'll make available access to the balancer, the control guy, the guy who can turn things on and off. One of the things I like to tell people is I don't do anything when I get on site. I can't. I don't own the systems. You do. You're building it. You've designed it, you're building it. I really don't own it. I'm the owner's representative. My job is to make sure that he got what he paid for and it works. So if you go back to the old days where we used to have that catch-all phrase, the system shall be demonstrated to the owner's satisfaction, well, guess what? Commissioning has become the owner's satisfaction, and we've made a process out of it. Functional performance testing is the heart of what we do. It's why I have 3 kits worth about $5,000 a piece of test equipment. My guys go around with their equipment. There's an amp probe in there, there's temperature sensors in there, there's data loggers in there. And what we use that stuff for is to prove that the Johnson system, the Huntington control system, the Siemens system doesn't lie. And you'll be surprised at how often we find that it does lie. I was once told by a Siemens tech that the sensors come out of the box calibrated. Excellent. How many feet of wire is there between that sensor and the field panel? What you don't know is there's a small adjustment in the Siemens system for wiring beyond 1,500 feet. Because of the resistance in the wire, it's a resistance-based thermocouple or thermistor. And if you don't have the right wire length, it's going to be out of calibration. They don't even tell their field techs that stuff. 99% of the time, never an issue. Every once in a while, a sensor won't read right. And as you dig in through it, you'll say, okay, well, how much wire is there on the sensor? Sometimes they'll coil a whole coil of wire up into the ceiling because they're not sure exactly where the sensor is going to end up. So they'll coil some extra wire in it. I did a central energy plant at Woods Hole where we had that issue. The wires ran a long way. So we try to prove that the system functions. And this is really the meat of what we do. If you were to look at my hourly breakdowns on projects, 60 to 70% of my hours are in functional performance testing. I'm a little different from most commissioning agents. There are a number of commissioning agents who spend more time up front and do less in the field. And I'll get into that a little bit when we get into the scope of work section. But our intention is to prove that the building works. These fans, these are 75,000 CFM each, and I think there's 6 of them in that line. This was from the Center of Life Science in Boston. They had bearing problems. And we're finding that more and more if you don't have ground rings on your motors and you have 18 and 24 pulse VFDs, you can have bearing problems. And we're encouraging most of the designers to include the grounding rings in their specifications for VFD-driven motors with high pulse count VFDs. As we get into selecting a commissioning agent, this is what LEED says. If a building is less than 50,000 square feet, pretty much anybody can do the commissioning and it would be acceptable to LEED as an upload, as long as it's someone who's responsible, knowledgeable, and has a reasonable resume. As you get above $50,000 square feet, sorry, then they want it to be more independent. It can still be part of a disinterested, I love that one. It's a disinterested employee of a subcontractor or general contractor, so it doesn't have to be me, doesn't have to be independent. Disinterested, and it could be the engineer. Unfortunately, as you get into enhanced commissioning, it excludes a lot more. So as soon as you go to enhanced, you almost are required to get into a third party, an independent third party. Selecting a commissioning agent, I love the fact that it says reality up there, because it depends on where you are in your phasing. I've gotten involved in projects and successfully commissioned projects after the owners moved in. And for those projects, it's like, geez, we're having so many problems. Let's bring somebody in and check this out. It works. I mean, you can call that a commission building. LEED would never accept it, but you could call it a commission building. I've gotten involved as early as prior to the architect being hired. I've helped some owners select their architects and engineers. And if you read through the ASHRAE Guide 0, you'll find that that's how they recommend it be done. My certification as a certified, let's see, what do they call it? Commissioning process management professional. Means that I know how to do all that stuff. Experience obviously is a key. Does the guy who's commissioning it understand what he's looking at? If I'm turning on and off boilers, say I've got a line of 300 horsepower hot water boilers, and they're on a reset schedule, okay? And I'm staging them on and off, and they're going through pre-purge and purge and light off, and then post-purge, and you know all the stages of lighting off a boiler. Does the commissioning agent understand all that stuff, or is he just checking off? I've got a sheet that I got from commissioning 1, 2, 3 off the web, and I'm checking off, yep, the boiler fired. Yep, the boiler's maintaining temperature. Yep, the draft inducers are working. Yep, I'm not getting a lot of condensation out of the stack, or I am getting condensation out of the stack. Do you really, does the commissioning guy really understand what it takes to maintain that? Does he know that it's got to be broken, if it's a fire tube boiler, it's got to be broken down once a year for cleaning? Does he know enough to see that there's not enough access to swing the doors on the back end of a Cleaver Brooks boiler? So these are things that checklists will get 80 to 90% of that, but does your commissioning agent really understand what he's looking at? A lot of people do only boilers. A lot of people do only chillers. A lot of people do just air handling systems. I like to think that we can do it all. We do have our weaknesses. What are our strengths and weaknesses? What trades can we do? There are commissioning agents that only do HVAC. We do HVAC, plumbing, and electrical, but I don't do building envelope. And I'll never flood test a roof, ever. But nor will I flood test a mechanical room waterproofing system. No way. There are plenty of other people out there who can do that. And I've subcontracted with a few. Do they rely on statistical sampling? Is statistical sampling fine? ASHRAE allows me to do as little as 20% of the thermostats and the VAV boxes in a building. Well, what happens if there's only 20 VAV boxes? Is that right? So, commissioning is going to vary, and it's kind of a buyer beware. Understand what you're going to buy. Your RFP needs to cover a lot of this stuff if you have to put out an RFP for commissioning. Do they rely on the construction manager? I do my own checklists. I'm not going to send you a CD that has all the checklists on it and say, okay, fill these out, although, Ben, we're doing that to you, aren't we? I'm sorry. I want to fill in the checklist myself. And the reason I want to do that is I've got two problems. I can't rely on the field to get the things done in a timely way. Not that they don't intend to do it, but your focus is not this stuff. Your focus is getting the job done and getting it installed. If I rely on you to fill that out, my labor commitment is going to be very uneven. I'll be there one day, I'm gone a day, I'm there another day, I'm gone a day, I'm there another day, I'm gone a day. I need to manage my own manpower because 80% of my costs are labor. So I want to manage the checklist. I want to maintain my own commissioning schedule. Does your commissioning agent do that? I'll sit down with you early on and say, okay, I need this many weeks. I need this many days for each air handling unit. I need this many hours for this. I need this many hours for that. Let's plug it into your schedule. And typically we key off of the ceiling grid. So we'll use the ceiling grid as a milestone and say, okay, now we need to start looking above the ceiling and do our installation checklist for VAV boxes, reheat coils, shields, automatic temperature control valves, access. And then as the ceiling gets populated, the balancer can start. And we typically will follow him with our performance testing. So, there's an awful lot of things in here that differing commissioning agents do to differing levels. And for me, this is kind of like my way of saying buyer beware. Rates, obviously, rates are a big deal. Like I said, 80% of my cost is rate. So if I were to suggest how you write a commissioning RFP, you need to take some of this stuff into account. What I've talked about up to this point is almost always related to new buildings. Existing buildings, there are two types of commissioning that are defined. ASHRAE definitions, the Building Commissioning Association, NEP, National Grid, NSTAR, they all pretty much use the same kind of terminology. Retro commissioning has been the term used for buildings that have never been commissioned before. And the utilities kind of locked onto this because it's their term for, let's study your building and find ways of saving energy and we'll give you money for it, whatever comes out of that. But typically what happens with that kind of a process that they call retro commissioning is you end up getting they'll finance the things that are good, that have quick paybacks, but there may be other things that could use commissioning, like most EDC systems need to be checked periodically. They're not going to fund that. So what do you retro commission? Recommissioning is the definition of buildings that have been commissioned initially, and this is just a relook at the same building. The cost of recommissioning a building typically is about 40 to 60%, depending on how complex the system is, of the original commissioning. Because at that point, it's just you're going back in and re-verifying the data. And again, you can do a sample there. That makes sense. You can do a sampling, see how bad you are, and then decide to go further or not. They all pretty much generally follow the guidelines and the recommendations from the 6 different organizations that certify commissioning agents. Existing building, O&M, this is in which version of LEED did this come out in? 2.2? 3? The intent here on LEED's part was to try and give owners some consistency in evaluating their building performance and some method of determining whether or not the building is still working. One of the things that we've determined by hindsight, I guess, but kind of in a bad way, the LEED energy model allows you to exclude in the performance over the base case, allows you to exclude a lot of things like process equipment. And one of the things that's happened is that ad energy model sometimes will get to the operator's hands to say, oh, the building should be costing me this much to run. Well, more often than not, it doesn't. It costs more than that. And this is an attempt at trying to resolve some of that. Some other people who are now getting involved in mandating building commissioning is our friends at the Code Commission. Massachusetts specifically says that the building inspector shall witness HVAC and electrical systems prior to issuing a certificate of occupancy. The appendix allows him to accept the report of an independent, recognized professional. Doesn't say who that recognized professional is, but it does say that it could be a commissioning agent. Could also be the design engineer. But somebody has to let the building official, so the Code Commission has put the building officials on the hook that they really aren't supposed to be issuing COs until they know that the energy using systems are working properly. The stretch code allows him off the hook by saying, okay, Mr. Engineer, you've witnessed it, give me the report. Or Mr. Commissioning Agent, you've witnessed it, give me the report. Then I'll issue. I have yet to have to file an affidavit or a letter, but it's coming. I know Newton is nuts about it. I picked up 2 jobs at LaSalle that all they wanted us to do is give them the stretch code letter. Do enough commissioning to get me off the hook with the building officials. And I think more and more as you see them go to their seminars, more and more of them will start enforcing this. Boston has started talking about it. They haven't actually said you must do this because they also want buildings LEED silver. So the energy codes, the building codes are now starting to pull this in. Florida actually has legislation on the books right now that requires commissioning to be done by a registered professional. Up to this point, most commissioning agents are somebody who's either certified by BCA, ASHRAE, NEB, TAB, AGC, the University of Wisconsin, and I forget there's a couple of others. But they all have very similar certification programs, and most commissioning agents fit into one of those. Some have multiple certifications. So what we did here is we created kind of a case study. This project was typical. This was a CI, Corporate Interiors Fit Up. And the air handling equipment and the main duct rings and everything else were existing. So it was basically got it, put in some high-tech conference space, put in good office space. The CEO gets a private bath and shower, and circulation. So it's pretty vanilla. I'll call it a vanilla office space fit out. It's intended to be LEED. We did a peer review of it. Some of the comments we made. In this case, we did a review of the design. You'll notice that there's an electrical comment on the end of it. The electrical plans didn't pick up the heat tracing on the hot water system. Rather than using a recirc pipe on the hot water, they used the electric heat trace. Electrical drawings didn't have it, so we picked up on some of that stuff. This one was a really easy one because it was an all-air system to start. So it's fan-powered boxes and VAV boxes. The second comment here was about a glycol fill. And they showed the dry cooler for the computer room units up on the roof. And there was no roof access other than a straight-up ladder and a hatch. And so we were like, well, who's going to bring up the 30-gallon drums to fill the system? How are you going to fill the system? Did they end up going DX? I think they did. Yeah. So they changed the computer room units to DX. So when we get to a point where we're ready to submit this to USGBC, we add a column that says resolution, or engineer's response and resolution, because sometimes the engineer will disagree with our comment. And the resolution may be something different than both of us started out with. So this is, in a simple form, this is how we do our design review. There'll be some things here, like the spec called out boiler breaching. That was kind of an oops, but there wasn't any fossil fuel burning equipment on this building.
It was a ghost. It was a ghost.
It was a ghost, yeah. I mean, it happens all the time. RFI number 1 is usually the one that says your spec says this, but we don't see any on the drawing. Sometimes we catch that before you get it. Actually, most engineers like this. Most engineers do, because you remember when we talked about time? We don't give them enough time to finish their designs. We really don't. We can't. There just isn't enough time in the process where it's costing us an awful lot of money to build the damn building. We want to get it done as quick as we can. Most engineers appreciate this because it's another set of eyes. Depends on how it's approached. And our approach is not to question his basis of assumption. It's not to question all those meetings he had with the users that decided that really this should be a VAV system instead of a 4-pipe fan coil system. Yes, sir?
Did you perform this review as part of a commissioning aspect or as a
This was under the enhanced credit point for a LEED commissioning. After we're past all this and you've built it, we're at the point where the ceiling grid has gone up, the balancer has come through, and this is one of my technicians using our own equipment. Remember I mentioned that I like to maintain my own schedules and my own time? Well, I can't rely on the balancer, I can't rely on the control guy. They've got different priorities. The balancer wants to go through and set his min-maxes and get all of his flow coefficients and all of his areas and all his VAV boxes done. I don't want to hold him up. I find it's much quicker to come in with my own stuff and just follow him along. And as I find things, in this case, this was Mill Harmer who was doing the job ahead of us. He fixed 50% of the things we found before we left. And very often, he's not wrong. Very often what we find is that someone cycled the power on the VAV box circuit and the flow coefficients got lost. The balancer had gone through. Very often we find that if we can get a draft copy of his report that has the initial flow coefficients that he took, the free areas that he took, we'll plug those in if we find them not right. And if the box works, we can say, check, the balancer did a good job. If we find it doesn't work, then the question is, why doesn't it work? Three of the fan-powered boxes here had bad motors on the fans. I think the last one's being replaced soon. Thursday morning, yeah. So as part of this is what we call our room testing. We're not really there to balance the building. We're there to verify that the work was done. We're there to verify that the flows are correct in the computer or in the system. Typically when we're doing this, we're also looking at the head-end computer. So again, I don't want to hold up the control guy because he's got different priorities. I want to go through and test every room, temperature control, lighting, airflow. And if the balancer has to do these readings for me, I'm going to hold him up. If the control guy has to do that operation for me, I'm going to hold him up. And the three of us trying to coordinate holds us all up. It's more efficient. Let him do his job. I'll come in behind him. Same with the control guy. But when we're looking at the building automation system, I'm looking at the graphics. I want the graphics done when I show up because I want to be able to verify that this thermostat that I'm taking readings here is addressed properly and it's in the right room.
Are the graphics typically far enough along for you to see that at this stage?
We insist that they be.
Why?
And it's difficult sometimes, I know.
Sure.
Especially if you're waiting on an owner for static IP addresses. Very often in our early commissioning meetings, I did a job at St. George's School down in Newport, Rhode Island. One of the first questions we asked at the beginning of our first commissioning kickoff meeting is, does this head-end system ride on the Ethernet that's provided by the school? The answer was yes. Okay, let's start thinking about static IP addresses because all the BACnet stuff needs static IP addresses. And very often, most of the field panels, almost all the Siemens field panels now work on static IP addresses. And it's become an issue because very often the IT guys don't want to have a system live in a building that's empty because they're afraid of losing their server. An awful lot of money gets put in the MDF rooms, and they don't. So what we'll do is we'll verify. Now in this case, it was a analog control system. This was a KMC system that went directly from the thermostat to the VAV box and didn't go any further. But if this was a DDC system, we'd make sure that the address of this thermostat is correct with the address of the VAV box, which is correct with the graphic output on the computer screen. And typically find 1 or 2% of the VAV boxes are addressed wrong. Another reason why statistical sampling becomes difficult. If you do a statistical sample, I might miss all of those 1% until the person in that office starts complaining every time I adjust my thermostat. Found that too. We use a VelociCalc to verify the temperature, the accuracy of the little red dial. It is nice to know that when you adjust a little red dial, it means something. So we do that. We typically try to get plus or minus 1 degree. If it's outside of plus or minus 1 degree, we'll flag it as an action item. Right, Rich?
Steve, I think it's important to tell everybody as far as when you get involved with the scheduling of this stuff, you are part of the sort of the team at weekly meetings, and what you'll let people know what you expect when you're going through.
That's correct. Yep. That's an important point, because I'm there, I mean, I'm the businessman in me is like, okay, I got to manage my manpower. If I'm not helping manage your schedule and my schedule and coordinating them together, we're both going to lose. When it comes to the after occupancy stuff, that's catch as catch can. We get in where we can. Some of our outputs, this is data logs that we're taking on this project, and all we're really trying to show here is over a period of 5 days that the black line, in this case there was no humidity control, which is the blue line. So the relative humidity was high one day and then it fell because the outdoor dew point fell. But in this case, what we're trying to show is that, yes, there is an unoccupied period where the air handlers are off. And when the occupied periods are in place, we know what the temperature goes down to, we know what it holds to. And these are just on-site computer data loggers. A lot of the woodworkers use them. The mill workers use them to verify that the humidity requirements in the space, it's same device, temperature and humidity sensors. The other thing that we'll do is this was the lights. Some of the data loggers we have measure lumens. And what we were proving here was that the lights go off on schedule and they come on schedule. There's really no rhyme or reason to the height of or the amplitude of the curves. That really was just sunny day, cloudy day. We can zoom in on this. If you were to ask me how many lumens was that, we can zoom in on it and show you that the lighting design was good and that it achieved the lumens that it was intended to achieve. If we're going to do that kind of thing, we need some input from the lighting designer to pick certain spots. In this case, we did it ourselves just to prove that the lighting controller was programmed properly. And this is our documentation. Action lists. If you look through the samples that I passed around, you'll see this. This is just simply what an item. If we find that a VAV box isn't working right, it's not achieving design, or the fan power terminal box is not operating, who's responsible for it, what its status was. We do go back and verify any item that we flag, we go back and verify. If you tell me it's finished, great. I'll go back and finish it. I'll go back and verify it. Most of the stuff that you'll see on our action list is operational. It's not delivering the right flow. The temperatures, the thermostat's out of calibration. It's not addressed correctly. I'm less interested in the quality of the installation, although we will flag something. But QC is the engineers and your responsibility to make sure your subtrades do what they're supposed to do and what their specification call for. So QC is your problem, not mine. Mine is, did it work? If I find insulation damaged, yeah, sure, I'm going to put it on my action list. If I find a diffuser's rusting because there's condensation in the ductwork, we'll investigate why that's happening. If there's missing shields, we'll pick those up. But for the most part, we're focused on performance-related things.
Yeah, you guys have a couple QC items here.
Yep.
Conduit, the insulation.
Yep.
That's a good one about the
We'll
water heater, huh?
We'll flag fire stopping too.
Yeah, I see that.
Yeah, the water heater, the electrician turned it on and didn't ask the plumber. So there's template letters we have to file. We have to put in all kinds of documentation. Solutions and recommendations. We will always put recommendations into our commissioning reports. How do I get the shaft of a fan out? Can I grease this thing? I've got some vane axial fans on a job that are in the vertical. And the guys who are running the building, how am I supposed to grease the motor inside there? It's in a shaft. It's a long way to the bottom. Cost analysis, commissioning fees, this is pretty straightforward. The subject project that we were working on was about 80 cents a square foot. That was that TI job. And it was electrical, plumbing, and HVAC. I've done commissioning as low as 25 cents a square foot for basic commissioning, a LEED a LEED Gold LL Bean store. 25 cents a square foot for basic, 10 cents a square foot for enhanced. Real easy, 5 rooftop units. I've done animal facilities that were $5 a square foot. And that's pretty much it. We do try to do an occupancy, a post-occupancy, lessons learned. We try to do that. It's hard sometimes to get everybody's attention after the job's done. But very often what happens is a dialogue in over email, go to meeting kind of thing. We try to do a lessons learned. Unfortunately, it doesn't always help the guy who's running the job that we commission, but it does help us all at the end to get the next job a little better, a little closer to being right. Questions? Hope I didn't get everybody to sleep. Anybody out there? Yes, sir.
I got a question. Several of the larger engineering firms provide commissioning services as a managed service. They would not qualify as a third-party commissioning agent?
Under LEED, they can if it's an independent, in other words, essentially if it's someone who wasn't involved in the design and someone who wasn't involved in the normal CA. So they can't take their CA guy who they assign to the job to do the shop drawing review and all that stuff and call him an independent commissioning agent. Certainly. Yes, sorry. Any other questions? All righty. Thank you very much. Appreciate you taking the time.